Okay, the next way that we're going to solve for delta H is calculate it using enthalpies of formation. Standard enthalpy of formation is going to look like this. Here's my delta H enthalpy. Standard, this little symbol stands for standard state, which is at 1 atm for pressure and 25 degrees Celsius, and this little F stands for formation. It's a hypothetical value that indicates how much heat would be gained or lost during the formation of 1 mole of this compound from its individual elements. So, this is methanol. This is the standard enthalpy of formation for methanol. What this means is this. When you make methanol from its parts, from carbon, from hydrogen gas, from oxygen gas, to make methanol, it gives off 201 kilojoules of heat for every 1 mole of methanol. Heat of formation reactions are always written so that all reactants exist as they would under standard conditions: solid carbon, hydrogen gas, oxygen gas. And there is 1 mole of product. So this is the enthalpy of formation, how much heat is required to make methanol. If you look in the back of the book, there's a table, and you're going to get all the enthalpies of formation for all different things. The enthalpy of formation value for most stable form of any element is going to be 0. So solid calcium is going to be 0. Solid silver is 0. Why? Because it doesn't take any heat to form calcium. It doesn't take any heat to form silver because it's already formed in nature. This scary looking reaction right here is actually very easy. The change in enthalpy for a reaction is equal to, this is sigma, the sum of the enthalpy of formations of the products minus the sum of the enthalpy of formation of the reactants. So basically it's this: products minus reactants. So this right here is the thermite reaction. This is the 2 balls that I smack together and gives off the sparks. Okay, here's my rusty ball right here, the solid rust, and the other ball I put some aluminum foil on it. Okay, smack them together, it gives off some heat. Okay, so we're going to do the enthalpy for the reaction for this thermite reaction right here. So we're going to do products minus the reactants. So it would be 2 irons, that's what the 2 irons are right here, plus 1 aluminum oxide, minus 2 aluminums and 1 iron oxide. Okay? If you'll remember, anything that's an element in its standard state is going to be 0. So this value is going to be 0, and that is going to be 0 right there. So basically it just comes down to aluminum oxide minus iron oxide. And the answer is negative 854.3 kilojoules per mole. Negative means it's an exothermic reaction, and if you'll remember, when I do smack the 2 iron balls together, it does produce some energy. Here's another one. If I was going to solve for the enthalpy for this reaction, it would be, once again, products minus the reactants. Okay. This guy right here is oxygen gas in its normal form. That's going to be 0. So I would do 2 SO2s plus 2 gaseous waters minus 2 H2S's. 2 SO2s plus 2 waters minus 2 H2S's and 3 oxygen gases, but this is going to be a 0. Okay? Where are you going to get these values? In the back of the book, you're going to get to use the appendix. I'll always give that information to you. This one has an answer of negative 1036.8 kilojoules per mole. It's also exothermic. And that's really just about it.